Hello, everybody. My name is Michael Oyiga, and I'll be taking you guys on interpretation of results and discussion. Your host is my friend. I met her during her final year, and she was just like you as well. And she called me, like she joined the class where I hosted that time, and then she was like the only person that had interest to continue. And look at where she has landed today. She's doing well for herself, and she's the first class degree. So hopefully, I hope most of you that just joined us, that just join her, will be able to like pass this knowledge that you gain through this class to somebody else. You get? So I know that I've been teaching you guys on several topics. My own topic is just interpretation of result and discussion. So when you start your project, or when you start okay, let's just start from the beginning. Let me just summarize. Say you are in your final year and you're trying to get a project topic. I think the mistake most people make is selecting a topic that they have no interest in. The moment you do that, you would find it difficult to continue. But anytime you pick topic where you say you really want to, your supervisor will always see interest. Sometimes supervisor they will always devil sometimes. So, but when you get good supervisor, then they see interest in the work. They will always try to support you to do your work. You get? So today we'll talk about interpretation of results and discussion. So if I want research now, my mind could do research gap, like which void I won't fill for with my research, which problem I want solve. Where somebody go feel reference, say, somebody don't do this work before, and the person find out, say so and so, they affect so and so. So most times, if you want to research, try find a research gap where you want fail. Even if somebody don't do that work for somewhere else, you can still do the same work on somewhere else as well, but then do one for urban area, you go do one for rural area, but so now how will they work? So if we want to talk about interpretation of results, you don't really know how to write research now, but so that this aspect of your project work now a vital aspect, because if you know do well, your field work, everything na jaga, because now him go talk wetin you don't do. All your introduction story where they write, you know, get ahead if this place not dey okay. You get? So how it works is, before you do your interpretation of results, make sure say your aim and objective they align properly, because those objectives na your result supposed to reflect, and your hypothesis na your result supposed accept. Might talk am again. Replay am na phone na video with this. You can just take it back. You can do as you pass. You can dropping dimes. No, but yeah, seriously. Your hypothesis is like the thing where you go mention, say, okay, like you know how you have a prototype. So like where you mention, say, I want to do something, but share this thing, I ain't gonna make her get head, or this thing no fit make her get head. These are my hypotheses, my H1 and my H1. Now, if I can't carry out my project and I see my field work and I do my analysis and everything, I come find and say, now that thing make that thing get head though, I will come accept my H2, come reject my H1. So my result and everything, it always reflects my hypothesis. So that's that. So that being said, when you are discussing interpretation of results, when you are talking about interpretation of results, your discussion too go follow on, because like descriptive parts of that result where you just do. Now how you go take explain them. For instance, now you don't carry out the calculation you want for this word, but you know sabi put them in writing. Now your lecturer no go come to help you, they explain your ANOVA, your correlation, your regression, allow you. Now you go explain properly. Then you write, okay, the value of this is greater, meaning that it's significant to this, but then you can't explain why it is significant to this. If you talk about recycling now, okay, this household that they practice recycling, they discover that they have 40% of trash, a flooded area in this area of land, because they recycle. But you know, go talk like you go explain like that bit by bit, but okay. So when we introduce research writing, we'll talk about how research writing follow the structured approach, how they should reflect your objective and your method. I just said it now. So there is a result section in your project. That's where you should present your data clearly. So what are key points in discussing interpretation of results? The first key point is you have to present your data clearly. For instance, if you want to talk about issues of gender. You know, say now 2 variable, but for our own part of the world, because I don't say other people outside don't get plenty gender now. But we will be just male and female, but so we will use chart to show the difference in your price. Maybe if you want to use bar chart now to show them, if you want to use histogram to show them. So you know, if you just write gender male and female 10, male 20, you will need to put them in those kind of tabulate them. Now that's a clear presentation. You can still use graph, like I said, and also figures as well. Yeah. So point 2, stick to the data. I know why I talk this thing, because most times if you don't do research and the thing don't be as if you need to enter, you can't use your hand, they increase p-value so that you will go where you want me to go, because later if you talk about p-value, so but when you use your hand, they push the p-value, make the thing go where you want me the thing adjust to. Allow you. Whatever data way you get, that research way you do, leave them like that. Even if the thing they support, like if you do research and you correlate, now still answer. If you show say there's impact there, now still answer. It means say you don't do something, but because people they feel like say where the thing show say yes there is impact, then you don't do it. And allow you. You get me? So number 3, you should always make sure you present pure facts. Make sure you present pure facts. For instance, now you don't write something they go, but because of say you don't say anomaly somewhere, you have to adjust. You start what do they call it? You start the rigmarole. That's the Jabuda report. That's very common in people when they do science, social sciences. They're very common with them. It's a bit adjust whatever for that place. They need to be English, they fool themselves. Maybe the lecturer they fool. You get. So after that, you also have to highlight your key findings, because most times we talk plenty talk. Our key findings now most times our lecturer they read that the audience they concerned about. Maybe now you talk about Fulani herdsmen and Islamization of the North. You know, if you talk about male and female, they have more males than they have more females. It's possible that they even have effect because they have more males and more females. So now more females going to do Fulani the herders, but it's even possible. But then there are other things that you don't talk about. For instance, I'm trying to see what you cannot talk about there. Let's see we talk about your sex. You talk about household, number of household. You don't really get effect, but because Islamization of the North. Why I say gender can get effect, because more males tend to be herders, but so more males mean there be more herders in the North. So that's the cultural factor. Now why I say don't follow. So once we have highlighted our key findings, we can move on to the discussion section. So if you want to discuss projects where you do, first thing first, you don't already interpret the data, but you don't explain how the result you don't explain the hypothesis, the research gap where you just feel. Another thing where you go know now, you're supposed to compare them with other projects. My own project was on, I can't remember. My project was on, what was the word? Determination of what did they determine why people they come outside come vote. The work had 3 people at the time, so my discussion was just Mr. Cletus Famous did this on this. I can't remember their name, but Cletus Famous was the major person that I referenced properly. So I was just intertwining all the works together. You get me? So you have to compare with different work. You have to acknowledge your limitations as well. You just be transparent. Say, okay, I for do reach like this, but because I get issue on this, I get issue I could not proceed to this, I could not proceed to that. You get me? Then also drop points for the future person we want continue from where you stop, or person we want do the same thing we do for another area. Drop points for the person. So you interpret the data properly, you compare with previous data, you acknowledge your own limitation, and then you put future directions. So I just wanted to explain what interpretation of results and discussion, so we can move on to highlighting statistical interpretations. Alright, so stats may seem complex. If you run statistics now, I think it is complex, but the minute you grab how to interpret the data, how to understand certain values, it could be very easy for you to move on. You get, for instance, now you know how SPSS work. You don't input your data, you don't analyze. It will give you results, but midway you see result now, you know if you don't understand what it is up for you, But once you be somebody who don't already grounded, you don't already know what to do. For instance, now your p-value is greater than 0.05, your p-value is lesser than 0.05. Wait till you go move on to, you don't even know about. So I'll give you a shortcut. Now, if you want tests for if they get statistical significance, so there's significance between this and this. Now p-value you go to look for. Now for our statistical analysis, it is that we will talk about if you get impact, or if you get significance, or if you get relationship. Impact, significance, or if you get relationship. So when we talk about significance between two variables, now our p-value they use. So our p-value, it means say if something gets 5% chance of happening, like this did not happen by random chance, like it did now something because I make it happen like that. So when it is greater than 0.05, our p-value, we always accept it true. We always accept our hypothesis for up. You get. Then when it is lesser than 0.05, meaning that it happened by random chance, we dey reject our HO. That's for significance. Now if we move on, we'll go to the test, t-test, where we compare two groups. So when you're trying to compare two values, like two variables, if they get the means of two variables, they get relationship, now t-test they use. You understand? So the t-test is used to compare the means of two groups to see if they are statistically different from each other. You understand? So when you measure the difference between groups related to variation with the groups, that's the value. So there are common mistakes people make in this. There are common mistakes people make in interpretation of results. So just because something they show relationship, let me say you will use. Okay, well, let me put it like this. When do you know to use correlation analysis, and when do you know to use regression analysis? So just because something they show, say, and they intertwine together, let me say that one and they cause that one. You get. So when they talk about causal factor, and regression analysis is supposed to use, you get me. So I already explained p-value. So t-test, to compare means between two groups, look for a significant p-value. For instance, now one check if male and female who they pass for inside one class. You get me? Then we don't check the mean value, and then we put them to our t-value and our p-value. So remember, I say when our p-value is less than 0.05, what will they do? If it is greater than 0.05, what will they do? So we show like 5% chance of this thing happening, means say it is significant, or if it get less than 5%, it means it is significant. You get me? Alright, so correlation, I explained already. Our correlation will show if two things they go together. It means say, for instance, I want to check how, give me something, let's say, is there a correlation between heart rate and exercise? Say if person they exercise, in heart rate could they go, I don't know how it be, I don't know how heart rate is the value, but maybe could they go how it's supposed to go. It's supposed to be yes, but there are other factors as well we go fit show am. You know me say na that one they cause am. It means say other factors to fit the way fit show am. Say it they work, but you know me say one cause another one. You get? It no imply say that this one they cause that one. It means say this one they show say na true if you dey do one, it they work. If you dey do one, it go they work like this. If you no do one, it go like. But this one they cause am. You understand? So but when you talk about what they cause am, go na regression analysis you can use. You understand? So for correlation, when it is +1, it means a positive correlation. But when it is -1, it means a negative correlation. Meaning say if it is positive correlation, it means say the one where the cause and be that. You get me? Say for instance now, if the correlation ranges from +1 to -1, perfect correlation now be 1. So it means say as that one they increase, the more you exercise, the more your heart rate they dey proper. You understand me? Then if it is 0, it means say there's no relationship between exercise and heart rates. Then if it is -1, it means they don't get any. It means say that like say they do anything. They still get breaking down of 0.7, 0.3, 0. But I don't have time for that. No time. So like it just means say like weak or no relationship at all, like that. You know how they break down pH scale and stuff. So we go to the regression. That's the causal factors, which is the cause and go. So it has its own value too. Just read up on it. ANOVA as well, chi-square as well. So yeah, all these things have their own value that you should read up on, and But the major thing is that understand this: when you interpret results, there are various values that you should note before you can proceed. But just know that for everything where you define, there's always a particular statistical method we're supposed to use. You understand me? Say you guys know which statistical method you're supposed to use for this particular one, because if you interpret your result. Because if you use the wrong statistical method for something, you don't really mess up your whole research. So what if the common mistake people they make? Because people they believe say, for interpretation, like greater than or less than 0.5 are the simplest rule for statistical significance. Once the p-value is less than, I don't explain that before, you reject, and once it's greater than, you accept your hypothesis. Causality versus correlation, meaning say no be causality they cause correlation. Causality now for regression, they cause that in a regression, but what they go together. Just because they go together, no means say that other one they cause harm. Then effect size down for occurrence with that. So, but summary of all these formulas: p-value, when the p-value, just note this one: when the p-value is less than, explain that one. T-test, when you compare, explain that one. Correlation plus 1, explain that one. Regression closer to 1 means that yes. So when you get regression, the model, once the thing they closer to 1, it means say that thing and they explain that model. It means that thing go and they cause that thing. It means that causality factor. So yeah. That being said, I've explained discussion, interpretation, values that you use. Alright, so that being said, you would have to understand this. You have to know how to maybe I will send her the file to get all the statistical shortcuts to know, so that you know how to analyze results. Once if you analyze, you go interpret your results. You get, I check a file now and I'm seeing p greater than 0.75. I don't know what to do. But because you don't already know, say okay, greater than, you know what you mean, less than, you know what you mean, if you proceed to discuss your results. So that's how it works. So all these things they work for real life examples. Like I use the heart rate and stuff. So that being said, research they stop. You have to continue researching on your own. And if you have questions, meet your host. She'll be willing to assist you. So I think I've covered what I can cover for this time. So thank you very much everybody for listening. And you can check me up on Twitter if you have questions. Oyiga Michael on every platform, I think. Or you can talk to your host. She'll be willing to help as well. So thank you very much. Blessings to everybody. Blessings.